We'll now introduce tastes into the model that we first introduced in graph 17.6, and we'll show that we can introduce the kinds of tastes that gave us the predictions in our simpler model from the earlier part of the chapter. Tastes can be modeled just with a map of indifference curves, just as we did in our development of consumer theory. The difference here is that the bundles over which the consumer now has tastes are not the same as the bundles that we introduced in the earlier parts of the book. In the earlier parts, these bundles were consumption bundles, where the consumer consumed the entire bundle. Here, the bundles are outcome bundles, where the consumer either consumes the consumption level in the good state or the consumption level in the bad state, depending on which state occurs. We can then return to my wife's case. She has an uninsured outcome bundle E, where she gets $250,000 in the good state and $10,000 in the bad state. If she faces a full set of actuarially fair insurance contracts, she can choose other outcome bundles along the line of actuarially fair insurance contracts we developed in graph 17.6. Her utility of the uninsured state is given by the indifference curve that passes through the outcome bundle E. If my wife behaves as predicted by the model developed in the earlier parts of the chapter, she will choose the full insurance contract C. This implies that for her, the highest possible indifference curve she can reach along the actuarially fair insurance contract line is tangent to that line at point C. The slope of the actuarially fair insurance line is -3, which means that the marginal rate of substitution at point C must be equal to -3. In order for the insurance contract C to be her optimal contract, it must be that the indifference curves that pass through other actuarially fair insurance contracts lie below the indifference curve that is tangent to the actuarially fair insurance line at point C. And in order for my wife to be the kind of person that always chooses to fully insure when offered a full set of actuarially fair insurance contracts, the same marginal rate of substitution that applies at point C on the 45-degree line must apply to all indifference curves as they cross that 45-degree line. More generally, if delta is the probability of the bad outcome occurring, the marginal rate of substitution of the indifference curves must be equal to -1 minus delta divided by delta as the indifference curves cross the 45-degree line. If this is the case, then the individual will always fully insure as predicted by the simpler model in the earlier part of the chapter. In my wife's case, delta is equal to 0.25, so -1 minus 0.25 divided by 0.25 is equal to -3. One implication of this is that for every actuarially fair insurance contract that involves less than full insurance, there's another actuarially fair insurance contract that involves more than full insurance, such that the consumer is indifferent between the two. For the insurance contract B, for example, there's an insurance contract D, such that the consumer is indifferent between B and D, where the consumer is underinsured at B and overinsured at D. An interesting feature of this indifference map is that the marginal rates of substitution depend on delta, the probability of the bad outcome occurring. This should make sense. How an individual evaluates different outcome bundles in this graph should depend on the probability with which these outcome bundles occur. So as the probabilities change, the indifference map will change.